Paycor provides payroll and HR software to small and medium businesses. We have over 40,000 clients in a variety of industries, and from recruiting and onboarding to benefits and payroll, our clients want to make an impact in their organization, and we help them do that. We're a fast-growing company, and we have plans to grow even faster, and to accomplish that, it's critical that we are always focused on improving sales productivity, and GeoPoint helps us do just that.
GeoPoint is an amazing tool that's helped us to be more productive in the field. It's helped us to increase the number of prospects that we're getting in front of, and it's just amazing technology that helps us be more prepared in the field. My team absolutely loves using GeoPoint. It saved them a tremendous amount of time, and so we've seen almost 2.5 more drops per week when we're using GeoPoint.
I use GeoPoint on my mobile app on an almost daily basis. It actually is very strategic in the ability to optimize a specific route and get through that route in the most efficient way possible. It allows me to visualize my geographic territory, see where the concentration of my prospect accounts are, and know where I'm going to spend the majority of my time so that I'm actually able to hit a much higher level of accounts that I would not otherwise be able to hit. Because of its integration with Salesforce, I'm able to click directly into the opportunity that I'm working on and add notes, add the visit, and log the drop that I may have done to that location. GeoPoint is an integral part of our sales process, and the utilization of it across our sales team is really impactful in us being such a successful organization.
As a territory analyst, I help create and equalize everybody's territories within their separate regions. It's really important to have GeoPoint so that we can manage the data so that our sales leaders can focus on managing their people.
GeoPoint has been a big win for our sales organization. When we were evaluating a mapping solution, we looked at a couple of different options, and ultimately we selected GeoPoint. These days, users are looking for intuitive, easy-to-use technology, and GeoPoint is just that. If you have sellers who are out in the field, GeoPoint is a no-brainer. It really helps them be more productive, maximize their time, and make sure that they're optimizing their client visits while they're out in the field.
We were just a bunch of nerdy kids who ignored the haters. We took their ridicule and we built on it. And when some of us gave up, well, we built on that too. Built resilience, built on a mission to make things a little better every day until the users came. Then the haters were VCs who scoffed at our audacity. This just isn't the way things are done. But we kept building. Users turned into teams, turned into companies, running their entire businesses on our apps. Then the software giants came after us. We weren't proven, we weren't fully featured, our radical cloud model wasn't secure. But we built on. And today, as companies adopt the cloud to move faster, teams are finding themselves slowed down by each other's efforts. The skeptics are claiming we'll never develop innovation at scale. But now, DevOps have come to the cloud, ushering in a new era of transformation. Companies can release on demand across hundreds of environments, innovating faster with fewer conflicts and fewer disruptions. There will always be challenges. There will always be naysayers. And we'll build on.
My name is Andrew Davis. I'm a product marketing director at Copado, but also the author of the book, Mastering Salesforce DevOps. This is me. I'm on Twitter also, and LinkedIn. You can find me over there at Andrew Davis IO. As mentioned, I work for Copado as a senior director of product marketing, which means I get to tell a lot of stories, more storytelling than code writing these days. But I did write this book, Mastering Salesforce DevOps, which you can get. And what I'm going to do with this session is begin to just summarize that book and a lot of the related topics. Okay, so this is very similar to a talk that I gave at Dreamforce in the fall, but I know when I've listened to teachings from useful sessions, I found it beneficial to hear them a couple of times, and I internalized different things at different times. So if anyone's seen my Dreamforce session, this may be a little bit similar, but anyway, really happy to be here with such a nice big audience at Virtual Dreamin. Okay, so if you're anything to do with the Salesforce development team, if you're a developer, you're a tester, you're an architect, a business analyst, planner, release manager, whatever. This is basically, it's always important to back up a little bit and think about, what are you doing? What's the team doing? What's the whole point of working together? Let me just tell you what your job is. So the job of a Salesforce development team are these three things: understand what people need, build it, and then make sure it works. And that is pretty straightforward, even though that's what almost all of the other sessions in this conference are about. That's what almost all the books and Trailhead and so forth is all about, doing a good job at these three things. I would argue that it's all fairly straightforward and it's fun. Like, I like building stuff. I like understanding what people need. I like testing and making sure things work. All of that is really fun. But that's not the whole job. There's some other things we need to do. We've got to do deployments. Now, everyone here is on this call because you hate deployments. That's my guess. I'm just throwing it out there. So deployments are often slow and manual. If you're using change sets, then, you know, it's not a great experience. Automating deployments is an easy win, and a lot of people you know, become interested in DevOps because of automating deployments. And so that's a great place to start. But that's not the whole picture. Still, you've got to keep your application running. You build an application, you've got to keep it running. Good news, Salesforce does that for you. That's the whole benefit of Salesforce. You don't have to run it yourself. But there's a few other bits, and this is what I really want to talk about here. Not only do you have to build something and make sure it works, you have to make sure it works well with everything else. And that is what architects help to do, is to make sure that all of the stuff that's being built is compatible with the rest of the system. Here's the trick. The more stuff you have in your Salesforce org, the harder this gets. If you've got a brand new developer org, just put whatever you want in there, no problem. If you've got a massive org with a lot of teams, the more stuff you have, the harder it gets to make sure everything works well together. You also have to make sure you didn't break anything else. And this is where testers really come in. And the more complex your org, the harder it is to make sure you didn't break anything else. And so the longer the testing phase may be. So if you look at these three together, these three stages together, these add up to what are known as lead time. And so lead time in the DevOps context is the period of time after you got something working, but before it's in the hands of the end users. So the lead time, the thing to notice here is that lead time gets longer the more stuff you add, or at least the whole thing, moving things through that lead time period is harder the more stuff you have. So that is very tricky. Now there's one final bit, which is making sure that users like what you've built. Now this bit about getting feedback from the end users, it's something that we don't always do a great job of as development teams. We're so busy getting stuff out there. We don't always check, well, are they using it? Do they like it? Are there improvements we can make? And the longer your lead time, the more of a delay before you can actually get that feedback. And so lead time is the enemy of feedback. So with Copado, we had a chance to do this survey, a state of Salesforce DevOps survey. We surveyed 300 companies around the Salesforce ecosystem, all sizes, all ages, not necessarily Copado users, just anyone. And what we found is that the more admins and developers you have on your team, the longer your lead time becomes. And why is it that your lead time scales exponentially depending on how many admins and developers you have? The more admins and developers you have, the more stuff they're pumping into the org, the more complex your org is, the harder it is to make sure that stuff works well with everything else and that you didn't break anything else, and the harder your deployments are and so forth. Teams are slowing down. Now, slowdown is a killer for innovation. Slowdown does not allow your organization to remain agile. So we know there's a lot of things that don't enable agility at scale. Manually recreating changes between dev and prod. I should add to this list, doing all of your customization in prod, working directly in prod does not scale. You need to stop. If you're doing that, stop it. So move to a development environment, but don't manually recreate your changes. Don't use change sets, for goodness sake. Don't just do one-off deployments on your laptop using Salesforce CLI. Get a system in place that's automated with version control You need to work on clear architecture, lack of effective test, and you need to work on having effective tests and so forth. There's a mindset shift that we need to go through, right? Because Salesforce is, right, what is Salesforce, right? Clicks, not code, you know, no software. No, it's not. It used to be 10 years ago, 20 years ago. It's not. Salesforce is not a no software platform. SASE is in the background. It's Cody the Bear. Cody the Bear is in charge now, and Astro and his friends, right? So we need to shift our mindset from just getting the basics, you know, my first process builder, my, you know, process builder is deprecated, my first validation rule, whatever. That's learning to drive stuff. But if we're part of big organizations, we're shifting into a different mode, which is traffic engineering, right? Learning to drive versus traffic engineering. You've got tens, dozens, hundreds of admins and developers, people who are modifying things in your organization. You need to figure out how to choreograph the movement of these changes at scale. Otherwise, the fun parts of your job are going to get washed away and you know, restricted, clamped down, occluded by all of these painful testing, change approval, deployment errors, architectural issues. All of the not fun stuff is going to get in the way of doing all of the good creative work that your company actually needs you to be doing. So we've got challenges keeping orgs in sync. We've got challenges tracking changes, propagating things systematically. We've got risks of interactions and side effects. We've got technical debt coming out of our orifices. So this is why we need DevOps, right? DevOps, if you don't want to read the book, it's a big fat book. Just memorize this slide. This summarizes everything. A bunch of foundational concepts. You've got development at the beginning, you've got operations at the end when stuff's running in production. In between, you've got this bit, innovation delivery. That's all your deployments and testing and feedback and so forth. I think development is mostly fun. Operations is mostly fun because Salesforce does it for you. This bit sucks. Like generally, this is not people's favorite part. We don't do a great job. In the Salesforce world, we need to up our game. It is 2020, we need to act like actual software professionals now. And we need to be improving our processes, and that's where DevOps comes in. So what is DevOps? It is basically, it's something called lean software development. Well, it arises out of what's called lean software development. So what's lean? Lean just means focus on the value that you're providing for the customers, for your end users, whoever is using your stuff, focus on the value for them, and everything else is waste. Everything that doesn't directly contribute to your bringing valuable innovations to your end users and ensuring that they have a trusted, stable, reliable experience is waste and nonsense. So all of the fuss that we make with deployments and testing and so forth, we've got to find an easier way to do all of this. So DevOps is a beautiful set of ideas. It's been about 11 years. It's been innovating in the IT world at large. There are books like the DevOps Handbook and the State of DevOps Report that give a lot of guidance. But basically it brings some of the best ideas in software development, best ideas in psychology and what leads to burnout, what avoids burnout, what leads to efficient processes, and puts them into practice in the software development phase. Just so you know what the word comes from, devs, developers, right, which it basically includes almost all Salesforce admins. Almost all Salesforce admins are actually click-based developers. They maybe spend some of their time doing real admin work, like, you know, giving users and assigning permissions and so forth, but mostly they're building new things, right? If you're building something new, you're a developer. You're changing stuff, and that is what developers do. They change things. If nothing needs to change, you do not need developers or click-based admins or anything. What does ops do? Ops in the IT world, these are your sysadmins, server admins, network admins, and so forth. These folks, what do they want? They don't want stuff to change. They want things to be stable, right? So what if you have one group of people who want things to not change and another group of people who want things to change? How do you get those people to work together? It's a challenge. It's a naturally conflicting motivation, but it doesn't have to be, right? Because everyone wants beneficial change. What ops wants really is stability. So that's where you come into this idea of innovation, creating something new and wonderful for your organization, versus stability, right? How can you do that without breaking stuff? How can you do that without making your end users hate you? And, you know, and they wouldn't hate you, of course, but be really struggling to have patience with you, for example. So there is this challenge, this what we refer to in Copado, we often refer to this go live gap, right? Where Salesforce provides this amazing platform, right? Easy to build stuff on, right? And you've got end users who want that functionality and need that functionality, but you've got a gap because you've got to figure out how to deploy things and test and keep your sandboxes organized. And all of this, Salesforce doesn't give you the methods to do that directly. You know, it's kind of up to you, right? But our teams, our companies don't always do the best job that we could with that. So that's where we need to improve. So one of the first things that I like to start with is visualizing the process, visualizing the development process, and getting some metrics on there. And the reason why this is important is because what you're doing is invisible, right? What you're doing, nobody can see the software you're delivering, and nobody can quite see the relationships the way you could if you were building widgets. If you're actually manufacturing physical widgets, you could kind of see what was going on. It's actually easier to think about. So when it comes to visualizing, there's something I'll show you later called value stream maps as a way to visualize, but you also want to get metrics. And what the metrics you want to get are actually end-to-end metrics. The metrics that really matter in a software development process are these 4 metrics that you're looking at here. So what matters is lead time for change. And that basically means from the time you finish something until it's running in the hands of users, how long does that take? Is it an hour, a day, a week, a month? That's your lead time. How often do you deploy to production? Is it multiple times a day, once a week, once a month, once a quarter? That's your deployment frequency. When you deploy to production, how often do you break something? How often is there a failure that interferes with end users' ability to do their work? That's your change fail rate. And if you do break something, at that time, there's only one metric that matters, which is how quickly can you recover? That's the only question anyone cares about, is how quickly can you get it fixed? And that's time to recover. If you look at these first 2, they deal with your innovation velocity, how quickly and regularly you can get changes out. These latter 2 deal with your stability and trust. Can you make changes without breaking things? And this is why these become perfect DevOps metrics. Dev focusing on change and innovation, ops focusing on reliability, trust, and stability. So one of the things that Copado is focusing on is rolling out metrics, embedding metrics in the development lifecycle, so you can actually visualize and track the metrics that you're managing. What we found when we surveyed folks across the industry is we found that we could categorize different organizations into these different levels of performance, from elite down to high, medium, and low. There is an elite tier of Salesforce teams that have a lead time less than an hour, releasing on-demand, change failure rate of less than 15%, and can restore within less than an hour. There's a low-performing group who take between 1 week and 1 month to deploy changes out. They release between daily and weekly, which seems not that bad, right? But it's still a lot less frequent than on-demand. But they have a high failure rate, and it takes them between a day and a week to restore, just like it takes between a day and a week to do a release. So if you look at the difference between the elite performers and the low performers, it's a massive difference. If you just look at the numbers, number of minutes versus number of releases, for example. So this is what we're trying to do, really improve the whole process end to end. So when we look at Salesforce Development, I'm not going to tell you how to build on Salesforce. You've got Trailhead and a billion other places to do that. What I will mention is that building stuff alone is not enough. You have to be thinking about architecture, and that just means thinking about some of the thinking beyond just that one component you're developing. If you're just getting started, you have one job, which is just do the little thing that I'm assigned to. The characteristic of a more senior developer, an architect, something like that, is they begin to think outside of just their one role, their one contribution. This is what architecture is. It's thinking beyond just your one limited space of work, thinking about the impact that it has on the other people in the team, thinking about the people in the future who are maintaining this, thinking beyond yourself and your narrow short-term requirements, and thinking especially about what decisions are you making that'll be hard to change in the future. Because sometimes you make decisions, but when you've made that decision, it's hard to change. That's really what architecture is all about. One of the main characteristics to watch out for architecture is what's called tight coupling. And there's a lot of aspects of tight coupling, such as just code that goes, you just write endless lines of procedural code. If you have a method that's longer than 10 lines of code, that is too long. No method in your code should be longer than 10 lines, in my not so humble opinion. No class that you have should be longer than 100 lines, ideally. So if your code goes on and on and on, it becomes very, very hard for people to think about it. That's one form of tight coupling. But there's many other aspects, like not having any packages, highly complex relationships, having relationships that sprawl across the entire org. All of these things make it very, very hard to maintain a system over time. When you talk about loose coupling, think about pizza compared to spaghetti. So this is your hunger-inducing slide for all of my people on a lunchtime time zone. Object-oriented design, modular architecture, dependency injection, etc. All of these things lead to a loose coupled architecture. When we look at the promise of Salesforce DX, and I'll say it's a promise because it's still very, very challenging for folks to get there. But if you look at the promise of Salesforce DX, you look at all of these tangled dependencies across the org. Everything depends on the account object, right? Everything depends on the case object. Reimagining those as packages with a much, much simpler dependency. Now, this might look complicated from some people's points of view, but it's a whole lot simpler than this one, right? So this is basically allowing this clear segregation of responsibilities so you know what areas are safe for you to change in your area of responsibility. So this is, the goal of packaging is reduce that complexity of the unpackaged metadata to just have this relatively smaller amount and begin to get packaged applications. Now there's some challenges with this, and shout out to my friend John Daniel, who's got a talk, Advanced Techniques to Adopt Salesforce DX Unlock Packages. They can be pretty advanced techniques. It can take a lot of refactoring, design patterns and different domain selector classes and dependency injection, mocking, all these kinds of things. It can be very, very hard to get started. So that's why you need to make sure that you've got a way to do a good job with your org dependent pipeline as well. And for most of us, it's hard to invest in the refactoring necessary to adopt packaging. We need to do a good job with our org dependent pipeline as well. Okay, so that's architecture. Now, all of that is kind of on the development side. What are you building? But then the big question in DevOps really is, how are you building? And the question is, do you really need version control? So a couple of my favorite screenshots come from almost a year ago tomorrow. Hey, happy Permageddon anniversary. I know we've forgotten about that small crisis, but when Salesforce made a change that disappeared a lot of permissions across a lot of people's orgs. So very challenging, right, to overcome that unless you have version control, unless you have a clear history of all the changes that have been made in the org and can quickly roll back to a previous set of permissions. There are two approaches to version control. One is what you call defensive version control. The next is called offensive version control. This is not their technical names, but basically defensive version control is just capturing passive snapshots, like having a daily snapshot, like having a daily backup of your computer. It gives some comfort, or having your stuff backed up to the cloud is the modern equivalent. Offensive version control, this means manually and intentionally tracking all of the changes that you're doing and associating those with the reason why you made that change. This is the real use of version control, but it takes a little bit of time, right? Because people normally need to learn Git. Unless you have one of these great commercial tools for Salesforce DevOps that helps you to track those changes with a graphical user interface. So I really I love using Git on the command line and in VS Code and so forth, but for wider adoption by your click-based admin friends, you need a nice graphical interface for that. Maybe they can learn Git, that's fine, but these commercial tools like Copado, I'm obviously biased, but they're enormously beneficial for your team. And track everything. Don't just track code, track all your configuration and so forth, except for things that you don't mind if people change them in production, but anything that has to be consistent between your different orgs, testing orgs, production, etc., track it. It all needs to be in version control. Not right away, gradually. And I'm yelling at you here, right? You probably taking all of this personally, and I'm kind of beating you up if you're not using version control. I'm not trying to be mean, right? I'm trying to say it's like people who tell you need to exercise. It's because you need to exercise, because you'll feel better, you'll be happier, you'll be healthier. It's these are there's a lot that can be said about these things, but they're for your own good, like your parents said, right? But it takes a little bit of time, of course, for us to build these habits, but we can at least start with the wish. So you've probably heard this term continuous integration. I would be letting you down if I didn't at least give you some education on what continuous integration is in a session like this. People talk about like, oh yeah, are you doing continuous integration? Yeah, I think we are. We have Jenkins or some tool. But continuous integration is a practice, it's not a tool, right? Continuous integration means these three things. It means that you're integrating the work of all developers and teams into a common code base, at least daily. So what that means is that if you and your coworkers are in different sandboxes or scratch orgs and so forth, and you're not getting each other's changes into your environment every day, you're not doing continuous integration. If your team has other parallel teams, like you work on Sales Cloud, they work on Service Cloud, somebody else does platform apps. If those code bases are not getting mixed on a daily basis, you're actually not practicing continuous integration. You're waiting to integrate until later. You're doing eventual integration. When you integrate those changes, you need a way to make sure that they didn't break anything. If you're integrating that frequently, it greatly increases the importance of automated testing. That's why running automated tests whenever the code base is changed is part of continuous integration. And just having and running those tests alone is not enough. You have to look at them and you have to fix them when they break. If you've had a broken build or unit test that's been failing for months, you're not actually practicing continuous integration. Continuous integration means when a unit test fails, you fix it. If this integration causes a failure, you fix that. The idea is to find errors as early as possible, reduce integration problems, and most importantly, enable refactoring. You cannot refactor the code base in any significant way if everybody's on different versions of the code base. And it's only like at the end of the week or the month that you integrate. Refactoring requires continuous small ongoing improvements to the entire code base. You cannot do that if your code base is fragmented and spread across lots of branches and teams. So continuous integration deals with this earlier part. Imagine all of your development environments, your development sandboxes and scratch orgs, your integration and then your testing environments, your production environments. Continuous integration deals with this early phase of things, the development phase. In Salesforce, when you're working with sandboxes, you'll typically use an integration org that you can deploy to make sure that all of the changes work together in this integration org, and then you can back promote to other environments. If everybody's working in the same sandbox and stuff, or the same production org for that matter, things can change unpredictably at any moment. That's a little bit too unpredictable. That's a little bit too much change for comfort. If you delay your integration by a week, a month, 12 months, that's too inefficient. So continuous integration hits this sweet spot in between. Continuous integration leads into quality and testing issues. So this is what the business requested, and then this is what you built, right? So there's this depth to what you're building that goes beyond what people can see. And so when we talk about quality and delivering quality work, I mentioned Lean is about delivering value and quality to end users. There's functional quality, which is do things do what they're supposed to do. And then there's structural quality. Is it built right? Is it reliable? Is it secure? Is it performant? Is it maintainable? How big is it? Because the bigger it is, the harder it'll be to maintain over time. So this is what, when we think about quality, it has these aspects, which means when we think about testing, we need to be thinking about all of these aspects. Testing is just a way of verifying quality. Most testing, manual testing, is functional testing in the sense that you're testing to make sure that it does what it's supposed to do. But if you're doing a code review, a lot of that's about maintainability, right? Some of it is about performance. And some testing deals with reliability. When QA people, put in weird values and test their edge cases and so forth, that's actually testing reliability. That's part of structural quality. Developers are, I'm a developer. Developers are terrible, right? They just want to get stuff done. They just want to push it out, right? They don't, yeah, it works, right? Well, but it only works if you do everything exactly right. And this is why developers and testers are indispensable friends, right? Because developers' job is to get stuff out the door as quickly as possible. Testers' job is to break stuff. They have totally different motivations. The role of a tester is to prove that something doesn't work. And so they are your opponent in the best sense of the word. They are like your martial arts sparring partner, something like that. They make you better as a developer. So you need to love your tester friends, as well as your automated testing assistants. So continuous integration deals with mixing changes across developers through version control and in the case of Salesforce sandboxes through deployments as well. And it deals with testing because you need to be running automated testing along with your changes. So when we talk about continuous delivery, what we're dealing with is we're talking about the end-to-end flow of changes out to the end user testing orgs or the production orgs. And here we're dealing with the question of environments, of controlling the environments, controlling every environment. There's a saying among sysadmins, traditional sysadmins, that as soon as you give someone access, what you call interactive access, like on the command line to a server, something like that, you destroy everyone else's knowledge of how that system was set up. As soon as somebody's logged into something and making changes, nobody else quite knows what it looks like now. So if you let a lot of admins into your UAT environment to make changes, because they have to, and because something was broken in UAT and we didn't have time to change it in other places, or you let people into your production environments and they're making changes in production and they're not in development, your environments are getting out of sync, it's gonna bite you, right? It's gonna come back and it's gonna make your life painful. Deployments are gonna fail that didn't fail in, deployments are gonna fail to one org that didn't fail to another org. Things are gonna work in one org, but not in another org. You're not gonna know what's actually going on. So this is because of this concept known as configuration drift. If you clone a sandbox and let two people into it, they get further and further and further apart and different. They never become more similar. Two distinct systems are never going to magically become more similar unless you have a strongly controlled process. And this is where continuous delivery comes in, where continuous delivery deals with managing the deployments to these higher environments, like the UAT, staging environments, and especially to production. It means moving changes out to these environments, but moving them out as quickly as possible and moving them in small batches and small groups. When it comes to continuous delivery, shorter release times are better in general. Deploying small changes means that if something goes wrong, you know exactly what did it. If you deploy 500 changes, right? You have a big end of the month release, you deploy 500 changes in that release and something breaks, how long is it going to take you to figure out what broke? Was it one of those 500 components? Was it the combination of them? Was it the combination with what was already in the org? That's a big detective research project. And that's why it's going to take you a day or as much as a week, who knows, to try to figure out what went wrong. Even though it may seem counterintuitive, more frequent deployments reduces the risk of failure for each individual deployment because it makes the changes smaller. Now, you need other things. You need good automated tests along the way. You need good testing process, good architecture. There's a lot of other things you need to really make continuous delivery work, but that is, that's really where we need to be heading. The term continuous delivery is written into the Agile Manifesto. Our highest priority is early and continuous delivery of working software. This comes 2001, like continuous delivery of working software to the end user. This is a screenshot from Copado just showing how the environments can be visualized, the flow of changes across the environments can be visualized. This is very, very powerful to get a visual window on what's going on across all environments. When it comes to Salesforce Ops, you have nothing to do, right? Salesforce is doing almost all the work for you. And so if you're a Salesforce admin, you're not really like a sys, in most cases, you're not so much like a traditional sysadmin keeping a system running. You're more like a click-based builder, a developer, like I said, that maybe works a little bit more closely with the business to make fast changes. So a big part of your role as an admin is to make things better. And a lot of that involves getting feedback from the end users. And often the admins are kind of a bridge between the business users and the developers, because the developers have to, it takes so much concentration really to work on a code level. And so that's why it can be helpful to have someone who's doing some interface with the business users and getting the requirements. But even for admins, you need to be following a dev lifecycle. Developers are forced to follow this sandbox, scratch org based dev lifecycle because of these Apex code quality guidelines. You can't deploy, you can't write Apex directly in production. Admins are not forced to follow that. They need to follow it anyway, right? You need to follow it. Why would an admin not want to follow it? Because it's slow and awkward and painful and not very easy to move your changes quickly. It's a lot faster to just make changes directly in production. So what is that telling you? Is it telling you that you should just make your changes in production, or you shouldn't use a dev lifecycle? No, it's telling you you need to make your dev lifecycle a lot easier, right? You need to make your dev lifecycle admin friendly, and you need to make it as fast, almost as fast as making changes directly in production, almost as fast and almost as easy and much less headache over time. So that again is the direction we need to be moving in. There's a lot that can be said on here. I want to give at least a little bit of time for some questions, but basically when you start looking at adopting DevOps or adopting any big transformation for the way you do development, you're actually beginning to look at a human problem. It's not a technical problem. There are technical challenges, right? And you need to get some technical skills like learning how to use version control and so forth. That's the easy part. In most cases. The more challenging part is to figure out systematically how to help your team change, right? And this is where there may be other people in the organization who have some expertise. There's a lot of good books on this sort of, this is what you call the technology adoption lifecycle, or the law of diffusion of innovations. The guide, the 8-step guide here on the right is from a book called Leading Change by John Cotter. All of these things deal with systematic change management. But when you're looking at what to change, the key is look at the whole system. Make changes that improve the whole system. Don't just change something because it's bad and you don't like it and you think that something better can be done. Change something that makes your entire team more effective. And to do that, you need to look at what's known as the theory of constraints. Don't really have time to talk about it here, but in any system, there's always going to be one thing. If imagine a hose where there's stuff flowing through it, right? There's always going to be one part of the hose that restricts the flow to the rest of it. You need to find that restriction and loosen it up. Like, what is it that's causing a slowdown? What's causing quality issues? Find that, work on that. That is your key. So this is a picture known as a value stream map, again, taken from Copado, just showing how these different roles fit together, like planning, development, integration, and how you can track metrics on each of these roles to see how everything, see the end-to-end process and the overall effectiveness, and work systematically towards making progress. Always starting where you are, looking at a next target condition, figuring out how to iterate daily, working daily on moving towards your next goal. And building that into your workflow, into standard work, into standardized processes. That standardization you may feel like it's cramping your style and your creativity, but standardization is the only way you can make changes that'll, in a way that'll last and always be effective. So communicate well, be bold, and have fun. The whole point here is helping yourself and everybody on your team to have a better time. So get this book, Mastering Salesforce DevOps, read the book. Great guide for every aspect of the dev life cycle. There's a lot in there. Mohit, you want to summarize any questions?
Yes, I have some Q&A here, Andrew, and definitely feel free to sort of put your personal thoughts as well on some of these. So one of the questions they have is, how do we reconcile that DevOps is easier to adopt when your org is not source-based, but rather org-based? In my opinion, DevOps become much more challenging in the latter scenario, but if you have any ideas around that, please share.
So you had asked the question, are we there yet in terms of DevOps for Salesforce? And then, can we really have DevOps on an org-based development versus source-based development? DevOps is not something that you ever get, or not something you ever arrive at. It's like efficiency, right? Are we there yet with efficiency? Well, I mean, yeah, we could be more effective. We could be more, it's a continual ongoing journey. You have to start with reality. The reality, this is what it's like now. And then your next step from reality is, what's the main limitation and how can we make it better, right? As opposed to like wishful thinking about, oh, I wish it was all better. That doesn't help. We need to be looking practically. So for org-based development, I would say, there's all of these commercial tools that make it easier. We've never had a bigger team at Salesforce working on developer tooling. The DX team is bigger than it's ever been. They're rolling out a lot of stuff. There's tons of room for improvements. We're all, have ideas about how it could be better and so forth, but it's a lot better than it was. Start where we are and have fun again.
Mm-hmm. So the other question is, what is the best practice to match Git to the Salesforce environment when there are a number of manual changes?
Okay, so reduce the number of manual changes is the first step. And that was why I posted that metadata coverage report, that I was shocked. There's 378 types of metadata that are identified now. When I started a few years ago developing, there was 110 types of metadata. So 378, so all these settings and so forth. Almost every time I hear somebody say, oh, this can't be deployed, it can. They just haven't found the way to do it. It takes a little bit of investigation to figure out what's the metadata API version of a manual change. So I bookmarked this page on the things that are actually unsupported. So do your best with Git and the things that are supported, and keep trying to reduce the manual steps.
And there is one more interesting question, which is how DevOps tool identify broken piece in Salesforce. Maybe this is not that clear about what broken piece is, but it's eventually asking like, can DevOps identify, technical depth in your implementation, or, code, code smell, or, the quality of that we have.
Yeah, if you think back to that quality slide, right? Functional quality, something that doesn't do what it's supposed to do, or structural quality, not built the way it's supposed to do. Yes, there are automated tools that can, there are automated tools that can give generic feedback. Static analysis tools like CodeScan can give generic feedback. The security scanning tool, checkmarks, can give security feedback. Your own unit tests are the best way to tell if you've broken something functionally. You have to write real unit tests. So DevOps doesn't magically do anything, but it can run your unit tests. And DevOps can help to shorten the time that it takes to get things out to users. And then your users can help you to identify issues and bugs as well. Shorten the time to get it to testers, shorten the time to get it to users. All of those things help identify quality issues.
One more question is, which tool did you use to get actual dependency image?
I used some combination. It was something that we built at Aperio with, it's maybe a little bit easier with the dependency API. So your easiest option now is to go onto GitHub, search for the dependency API. Andrew Fawcett created a nice repository with some graphic visualization tools. That's not exactly the method that I used, but it's sort of the best published method that's available.
Awesome. So other question is, how about the hotfix scenario when tests are already on UAT and the hotfix is going to touch components already rested on UAT?
Okay. So the fact that you have a hotfix environment means that your system is not really optimal yet. Like the fact, if you have a hotfix environment, that means that the only reason you have that is because the normal process of getting changes out is too slow and too inefficient. And so you might need to have a hotfix environment, but you'll need to make sure you get those changes into production, but back into UAT as quickly as possible. And eventually you want your main pipeline, the sort of main flow of changes, to be so fast and efficient, you don't need a hotfix environment. You just put something into development and send it through and it updates UAT in one direction. But we have these long cycles, and this is what I was referring to with long lead time. If you have a long cycle, you do a deployment once every 2 weeks, something like that, then that's why we do these manual choreographies, like some manual dance where you've got to move things from hotfix to prod and back into UAT, and it's kind of a slow dance.
Yeah. One thing here I want to quickly mention is a lot of people have questions around Copado tools. I'm not going to ask questions about them. I'm going to recommend them that they go to the booth. So we have a booth at the virtual Dreamin conference, and there I think there are more experts like Andrew, where you can get more questions answered about your product questions. So I'm just picking up like in general some of the questions. So sorry about that, but those of you who have questions, feel free to actually go there and ask, or in fact they can reach out to you, Andrew. Is that correct?
Go to the Copado booth. They'll be actually faster. I'm not as good as I should be at responding all the time, but I'll go over to the booth after this. I'll go over to the booth after this and be available there for a while.
Yeah, awesome. So the other question is, I find a need to have a smaller and often customized version of the integration part, code base that is possible to push to scratch or by devs doing their tasks. Is there any code will push to scratch org list? Sorry, I didn't get the question properly here. Somebody like, I think it's Rune. Rune, if you could, rephrase your question, that will be a lot better for us. So here's another question. We have separate sandboxes for every developer. Now I understand that merging of code is one thing, why we should consider DevOps strategy. But apart from that, any other important things we should consider or something we would gain using DevOps tools? We use GSA today is our response. So yeah, about sandboxes and merging, what should be, some of the recommendations?
Yeah, the term DevOps is kind of, just begun to come into the Salesforce world and become really popular in the last couple of years. And so it's not, we don't, we use the word not very, very awkwardly, a little bit incorrectly sometimes. But think of DevOps as a term like efficiency, like I said earlier, right? So DevOps really is a mindset. And there's three aspects of the mindset. Basically, you need to, the basic aspect of the mindset is you need to be on a learning journey, and a learning journey of continually making your process deliver more value to the end users and identifying waste within that whole flow, so that your team is more and more effective. So you're already kind of doing DevOps, of course, and having multiple sandboxes and so forth. Where you should start is just making sure you can map out your whole system and begin to get some metrics, and then to begin to think, what are the main things we want to work on? Is it reducing the time it takes to get changes out? Is it improving the quality? Is it easing some of the process so that our team can have more creative energy put into the actual development? Mm-hmm. And for every team, the answer is going to be different. There's no one-size-fits-all solution. So for you, and in fact, I would recommend only focus on one thing at a time. Like focus on one thing, make an improvement, make it stable, then do the next thing, right? It's just like, we don't want to have like physical fitness goals and then also work harder goals and improve our relationship goals and read more books goals all at the same time, right? It's, it's hard to do everything at once. So yes, DevOps is the attitude. And yes, of course, there's improvements can be made in your system, and you're the best one to help find those.
Awesome. All right. I think we are very close to time, Andrew, and I really appreciate your time here and appreciate everyone's time. This was a great session.